grade 11. How are you? Now we are going to take our physics. Types of motion. We have two types of motions. Translational motion is the first type and the second type periodic motion. What about translational motion? Translational motion means that we have an end point and starting point. Like what? Like the starting point of a car in the race and its ending point at the end of the race. Translational motion can be in curved path. But in the periodic motion, what is the difference between the translational motion and the periodic motion? Periodic motion is the motion that repeats itself regularly in equal intervals of time. Periodic motion can be classified into two types also: wave motion and oscillatory motion. Wave motion like the water, but in oscillatory motion like in the pendulum. Oscillatory motion. We can classify the oscillatory motion into four important concepts. Like what? Like vibratory motion, amplitude, displacement, and complete vibration. What is the difference between these four concepts? First, for the vibratory motion or oscillatory motion, it's the motion made by a particle on both sides away from its rest position, like the pendulum. Here, the starting point or the equilibrium position will be this point. We called it by M. Can we have the maximum displacement, which called the amplitude, for this pendulum? Yes, from M to A. We can say that this is the maximum displacement. Another name for it is the amplitude. What is the amplitude? It's the maximum displacement done by a vibrating body away from its rest position, or its distance between 2 points where the velocity at one point is maximum. What do we mean by this? We mean that point P here is the maximum velocity, so it can have the maximum kinetic energy during the motion. But before the motion, we can say that it's the rest position or the equilibrium position. But here in C point, our kinetic energy will be equal 0. At the maximum displacement, our kinetic energy will be 0. But what about the potential energy? Potential energy is the maximum. So we have a relation between the potential energy and the kinetic energy during the motion of this pendulum. Kinetic energy decrease and potential energy increase at the maximum amplitude or displacement. We can say that Potential energy is at its maximum, but kinetic energy may equal 0 at the other side in C point. And so the velocity can be also 0. We can say that amplitude is the distance between the position at which kinetic energy is maximum, like here in P point, and potential energy is 0, like here at C point. The second concept, displacement. It's the distance covered by the body between its position at any instant and its position at rest. What this means? We start our motion from the rest position, but any point here at this path may make the displacement, not the maximum displacement amplitude, but any point here or in the other side at AP, we can say that this is a displacement. So the distance covered by the body between its position at any instant and any point else may called displacement. Complete vibration or wave form. Complete vibration means that we have a motion or vibration passes by a fixed point. This fixed point, we pass through a fixed point 2 successive times in the same direction. So we can say that from B to C and then CP, BA, finally AP, these are called the complete vibration. We have 4 amplitude in the complete vibration: PC, CB, BA, and AB. What do you know about the periodic time? Periodic time is the time taken by vibrating body to make one complete vibration or cycle. The rule for the periodic time, T capital equal T small, which means the time in second, but T capital the periodic time. So T capital equal T small over N. What's the N? In number of complete oscillations taken by the body. So we can also say that T equal 4 times time of amplitude. What about the frequency? And what is the measurement unit for the frequency? The measuring unit for the frequency, hertz or cycle per second. What is the frequency? It's the number of complete cycles of vibration done by a vibrating body in 1 second. We can say that frequency measuring unit may be kilohertz, which means 10 power 3 hertz, or megahertz, which means that 10 power 6 hertz. The symbol for frequency, nu. Nu equal N over T. N for number of oscillations and T for the time. Important notes. If we have two bodies vibrate having the same phase, that means they have the same velocity and directions. For A and D have the same direction and velocity. This direction is the same, okay, and the same velocity. But in P and C, we have the same direction, but not the same velocity. What is the meaning of motion of a simple pendulum? Motion of a simple pendulum means that we have a displacement increases from the starting point A to the maximum value B. Then it decreases to 0 at A, then increases to negative maximum value at C. So, when we start motion from here, potential energy must be at the minimum or equal 0, but the kinetic energy is maximum. Then we move to the maximum displacement, maximum potential energy, but the kinetic energy started to be 0. And then here kinetic energy will increase to its maximum, but the potential energy decreased. And so again, the kinetic energy decreased from here to here, and then the potential energy become at its maximum, and so we make the last motion for complete our vibration from here to this point. Okay, this point will be the end of our complete oscillation. Energy or mechanical energy equal kinetic energy plus potential energy. What about the rule of kinetic energy? Kinetic energy equal half mv power 2. What is for this m? M for the mass, but v for velocity. But in kinetic in potential energy, mgh, h for the height, g for gravitational acceleration, and m for the mass. Notes. If the body starts motion from the position at which the velocity is 0, then the curve is drawn as sine curve. This is the sine curve. When we start from 0, so our velocity starting from 0. But when the body starts its motion from the position at which the velocity is maximum, like here, so we start our motion from a number in the velocity. Okay, so we can call this pi curve cosine curve. What is the wave? It's a disturbance that can propagate, transferring energy in the direction of propagation without any transfer in the medium particle. So we transfer what? Transfer energy, not transferring the medium particle. We can classify the waves into two types: mechanical wave and electromagnetic waves. What about the mechanical wave? It's a disturbance because we said wave, so it's a disturbance. This mechanical need a medium, but in electromagnetic waves we can propagate in space or other media. Mechanical, it's formed from a transverse or longitudinal waves, but in electromagnetic transverse only. So electromagnetic waves don't have any longitudinal wave. We have some examples for the mechanical waves, like the sound wave, but in electromagnetic waves, like the light. Mechanical waves, like the water waves, waves produced through vibrating strings, or the sound wave. But electromagnetic waves, like light waves, X-rays, and radio waves. Mechanical waves, disturbance that propagate in a media. Electromagnetic waves is the wave originated from a vibrating electric and magnetic field. So we have two fields, magnetic and electric, which consist the electromagnetic wave, like here. Give reason. We see the light produced from the cosmic explosions, and we don't hear the sound. Why we don't hear the sound from the explosion in the space? Why? Because between the earth and the sun we have a space, not a medium. So the sound can't transfer through space. Because sound is a mechanical wave which need a medium. But light is electromagnetic waves that can propagate through the space. Why, or give reason, astronauts used wireless devices on the moon's surface? Because there is no medium on the moon, so the sound can't propagate. Why? Because the sound is a mechanical wave. Conditions required for producing mechanical waves. How can we produce a mechanical wave? Vibrating source, like a pendulum, fork, stretched wire. Disturbance, which means the wave to transfer energy. And a medium that carry the disturbance. Mechanical waves can be transverse wave or longitudinal. Let's have the first type. Transverse waves. What is the form for the wave of transverse wave? This wave consists of a crest and trough. The direction of this vibration must be perpendicular to the direction of wave propagation. The distance between any two crests and any two troughs, called the wavelengths, which take the symbol of lambda. Transverse wave, like the waves in strings and wave in water surface, but in longitudinal waves we must have the rarefaction and compressions. The direction of vibrating from medium particle along the line of wave propagation, not perpendicular like the transverse. Distance between any two rarefactions, or the center of the rarefactions, or any two compressions. This is called the lambda, the wavelength. For examples of longitudinal, like sound waves in gases and waves inside the water. Main point: propagation of the transverse wave in a medium requires the ability of molecules of the medium to vibrate and the existence of certain cohesive forces between the molecules of the medium. Therefore, it's transfer in liquid and solid, but not propagate in gases. So here we can say that sound wave in gases, like the light, okay? Sorry, like the sound. Main point: when wave is occur in water, then on the surface we have transverse wave, but at the depth we have longitudinal wave. To calculate the wavelength, lambda x over n. X is the displacement covered by the wave, but n number of the waves. When we need to calculate number of wavelengths starting from the crest or the trough to another one of the same phase, then number of wavelengths equal number of greater order minus number of lowest order. Calculation of number of wavelengths starting from the trough to the crest means that when we have trough and crest, this means one for the crest, like here, one for crest and the other one for trough. So we must make minus half. Number of wavelengths equal number of the greatest order minus number of the lowest order minus half. Number of waves. We can calculate the number of waves by x over lambda. Amplitude of the standing waves equal the vertical distance between crest and the trough. So when we have this, how we can get the amplitude? Amplitude of the standing wave, vertical distance between the crest and the trough. So when we have the amplitude for crest only, we take the maximum displacement here and the zero. So this is the amplitude. And also for the trough. The figure shows, let's have the answer in the class dojo. Okay, I will send it. How can we see objects? Electromagnetic spectrum. It's the distribution and arrangement of electromagnetic waves according to their wavelengths or their frequencies. The visible spectrum from 400 to 700, okay? Light propagation, let's have the light propagation. We have some properties of visible light waves. Light reflection. When a light ray falls on a smooth surface, so this light ray called the incident light ray. This point is the starting point for the reflected light ray. Between these two light rays, we found two angles which are equal to each other: angle of incidence and angle of reflection. The sample for angle of incidence, phi 1. Angle of reflection, phi 2. Light refraction. Refraction means what? We have incident light ray and a refracted light ray. Incident light ray with the surface makes what? Makes two angles. Angle between the normal line called the incidence angle, phi 1, but angle in the normal line, between the normal line and the refracted light ray, called the refraction angle, theta. The light refracted between two optical media due to the change in the velocity of light. So we have two velocities, v1 and v2, so that n from medium 1 to medium 2 equal v1 velocity on the medium 1 and over the velocity of medium 2 equal sine phi over sine theta, angle of incidence and angle of refraction, equal lambda 1 over lambda 2 equal n2 over n1. So n from the medium 1 to medium 2 equal n2 over n1. When light ray travels from less density medium to dense medium, the velocity of it decreases. Then it refracts towards the normal line. This means the angle will decrease or increase. This means the angle will decrease. Then it refracts towards the normal. Theta here decreased. So, velocity 1 greater than velocity 2. Velocity in the first medium greater than velocity in the second medium. When light ray travels from dense medium to the less density medium, the velocity of it increases, so it refracts away the normal. So the angle of refraction will increase. So when the light ray travels from the less density medium to the dense medium, the velocity decreases. So v1 is greater than v2. Then it refracts towards the normal line, which means that the theta or the refraction of angle decreases. When the light ray travels from a dense medium to the less density medium, the velocity of it will increase. So V1 decreased from V2. So this light ray refracts away from the normal line and gives the refraction of angle increasing. So the angle of refraction increased. But if the incidence ray is normal to the surface of separation, so this phi or angle of incidence equals 0, but theta here equals 0. Thank you, grade 11, and goodbye.